All right. Today we're going to discuss correlation. I'm always happy to get to this topic as this is when I really feel like we start to get to kind of the meat of the course, or well, maybe not the meat. Some of you, I'm sure, are vegetarians. Uh, the main course, let's say, the biggest pieces, the stuff that people actually use to do statistical analyses. So correlation is the first of these techniques. So we've kind of moved out of those foundational issues like normal distribution and probabilities, and now we're starting to get to the stuff that people use in analyses. So we'll start with correlation. All right, so as an example, let's say that we developed a new measure of test anxiety. That is the feelings, feelings of worry and anxiousness that happen when you know that you have a test coming up. Some people suffer from test anxiety. Some people have no problem taking tests. Perfectly normal to be anxious when you're being evaluated. So imagine that we've developed a new measure of test anxiety. We have 102 false items, and this is from an actual scale. Questions like, while taking an important exam, I find myself thinking of how much brighter the other students are than I am. If I were taking an intelligence test, I'd worry a great deal before taking it. If I was going to take an intelligence test, I would feel confident and relaxed. When taking an important exam, I perspire a great deal. So questions of this sort of nature. During class examinations, I'll find myself thinking of things unrelated to the actual course material. So for a scale like this, you would probably just count up how many yeses people said, and people with more yeses who experienced more of these things would be thought to have higher test anxiety. So we can look at scores on our test anxiety scale and ask some questions about it. First, we get a mean and a standard deviation, a low score and a high score, all those descriptive statistics that we've seen before. But we'll see that sometimes the questions that we want to ask go beyond these simple descriptive statistics. We want to know something more about the anxiety score. There's other things that we would want to know about this score. In particular, the questions that we might want to ask about the scale are things like, well, do these anxiety scores actually relate to exam performance? If we're proposing that test anxiety is something that makes people perform worse, then we're going to have to demonstrate that test anxiety is in fact related to worse exam scores. If our scale that says it's measuring test anxiety is unrelated to how people actually do on exams, then it's probably not a very good scale. So we want to demonstrate that this scale is related to the things that we think it should relate to. In particular, exam scores are one thing. Other things we might look at, this should probably relate to general anxiety. Test anxiety might just be a subset of general anxiety, depression type constructs as well. But we're going to take a look at how this relates to exam performance. Another question we're going to ask is about the stability of this measure. If we have a good scale that measures something that exists within a person, every time a person takes it, they should score roughly the same. We wouldn't expect them to score, if they scored 70 the first time, we wouldn't expect them to score exactly 70 the next time necessarily, but it should be somewhere around there. We wouldn't want people scoring 70 one day and 5 the next day. That would suggest that the scale lacked stability and maybe wasn't measuring what we thought it was. So the new question that we're interested in here is not what does the distribution of scores on test anxiety look like, but how does that distribution of scores relate to the distribution of scores on exam performance? So our exam, we can also get descriptives for that. We have a mean of 52, standard deviation of 25. You can see the low score, the high score. We've got descriptive statistics for the anxiety scale. We can see that the means and the standard deviations and the ranges are relatively close to each other, but that really doesn't tell us anything. It doesn't tell us whether people who are higher in test anxiety tend to also be lower in exam scores or whether there's no link between them. So we want to ask a new type of question. This type of question goes beyond the descriptions that we've used before, which describe a single variable. We're going to now describe two variables. We're going to look at our first bivariate relationship. And all bivariate means is two variables, the relationship between two of the variables. And that's where the correlation comes in. Now, if we expect anxiety to relate to exam performance, We would probably expect that people who had more test anxiety tended to do worse on exams. Anxiety has this this way of shutting down your cognitive resources. It kind of takes over your brain. Hard to perform well under those conditions. So if we're actually measuring test anxiety, we would expect it to relate to worsened exam performance. And again, it's important to establish that our measure is actually measuring what we think it is. Really, one of the key issues that you'll talk about in your research methodology course next semester is what's called validity. And this is a form of validity. Does our scale actually measure what we think it is measuring? One of the big concepts in that class. Are we getting at what we think we're getting at? So here's a graph of the relationships. Again, the techniques like graphing that we've used before don't really show us anything up to this point. They don't really help us to understand how one thing relates to the other. The issue is that, we've got people who are high in anxiety up here in the upper end of the scale. We have people who are high in low in exam performance on the other end of the scale. We don't know if those are the same people. We don't know whether those are the same people or not. We don't know whether it's the people who are high in anxiety that are the ones who are scoring lower on exam performance. We just don't have any idea at this point. So just like the descriptive statistics we saw, the data visualization techniques that we've used previously really tell us nothing about any sort of relationship between anxiety and performance. So this kind of takes us back to where we started. Now we have data from a bunch of people. We have their anxiety scores, we have their test performance. We could go through and look at every single score and see if we could find some sort of relationship. But of course, we have better ways to do that, better ways to organize it. But again, we are faced with a situation, we've got all this information. We want to summarize it in meaningful ways. We're going to see that we've got two main ways to summarize this information. One way is graphically, which helps us get a sense of what the relationship looks like. And the other way is going to be numerically, and that's what the correlation statistics that we look at are going to be about. So again, whole bunch of data. We got to bring some organization here. And that's where we're going to use statistics to organize the information to describe not just anxiety and performance, but how anxiety and performance are related to each other. So the new strategy that we're going to use to start with is that we're going to graph pairs of scores. For every person, for example, the first person here, we're going to graph their anxiety score and their performance. We'll put anxiety on the x-axis, performance on the y-axis, and make a little dot where those two intersect. We're going to do this for every single person. Every single person is going to be in our graph. And that graph would look something like this. This is what's commonly called a scatter plot. It shows the relationship between our two variables. And one way you can look at this is I like to start looking left to right. With left, the people with lower anxiety, the left side, the people with lower anxiety, they tend to have higher exam performances. That is, the people who are less anxious tend to do better. Then as we move across the graph to the right, we can see as anxiety is going up, performance is dropping. And that's exactly what we would expect if we had measured if we're actually measuring test anxiety. Those people who suffer from more test anxiety should quite reasonably be doing worse on the exam, and that's what we're seeing. Now, that doesn't mean that every single person who has low test anxiety does great on the exam. It doesn't mean that every single person who has high test anxiety does really poorly on the exam, but it's the general pattern that we observe. There's a tendency for people who are higher in anxiety to have worse performances. One strategy that we'll see that helps to identify these patterns, we might draw on a line here. And this line here will become really central in the next topic that we deal with, which is called linear regression, which is all about fitting a line to data. That's kind of algebraic stuff. Don't even worry about that. I have no idea. I had no memory from algebra of lines and stuff like that. I probably never actually learned it, but within the context of statistics, it's not a complex concept. All right, we could also ask whether people's scores are similar at both and multiple administrations of the scale. Important to show that a scale has some stability. This is what's called in the measurement field as reliability. A big concept in psychology, we want our measures to be reliable. That means that we want the measures, if they're supposed to measure something stable, to show roughly the same results each time somebody takes it. You can liken this to getting on your bathroom scale. If I got on my bathroom scale and it said 150, and I got it on it again the next day and it said 150, say, hey, wow, that's pretty consistent. It's giving me the same result each time. Of course, if my bathroom scale said I was 150, it would be totally wrong, but it would be at least consistent. So we want to be not only measuring the right thing, but we want to be consistently measuring it. And that's what this question here is getting at. Are we measuring the same thing? Are people coming up roughly the same? So again, descriptive statistics don't really help us. We could have the same mean, same standard deviation, same low and high scores, but that doesn't mean that it's the same people providing the same scores. Doesn't mean that at all. So it doesn't tell us how people score relative to each other. So if scores were consistent, we'd probably expect something that looked a bit like this. Just about everybody scoring right around where they scored the first time. And we see here, this is a line, this is a relationship that's going up, meaning that people who had higher scores the first time they took the scale had higher scores the second time they took the scale. People who had lower scores the first time they took the scale had lower scores the second time they took the scale. All right, I'll stop here and we'll move to the next section.